Okay, so we're going to start with this right here, but spend most of our time with the confidence interval. All right, so we were talking about the null hypothesis before and the alternative hypothesis. An important thing to understand is that you can reject the null hypothesis, but you can never accept the alternative hypothesis. Why? Because we're not testing the alternative hypothesis. What we're testing is the null hypothesis. Right? So you can say, nah, I'm going to reject the null hypothesis, and you can say, I'm not going to reject the null hypothesis. But you can't just go ahead and start talking about another hypothesis that we're not testing. You can't just accept the alternative hypothesis. You can only fail to reject the null hypothesis, not accept the alternative hypothesis. That's an important distinction. It doesn't matter in terms of step one, but it's just an important distinction. Okay, and there are three things that you look at here. Type 1 error, type 2 error, and of course power, which is related to type 2 error. There's nothing here. They just wanted to make a square. All right, so let's start with type 1 error. Type 1 error is the most important error. Why? Well, at least that's how I think about it. And the reason is you can think of it as the most important because type 1 error is you send an innocent man to jail. And in our justice system, for better or for worse, there's that whole thing about, oh, it's better to let 1 million guilty men go free than one innocent man go to prison. So that's why that's type 1 error. Type 2 error is the opposite. Here it's you let the guilty man go free instead of letting the innocent man go to prison. So what causes that? Well, I like to think that you weren't strong enough to grasp the null hypothesis. There wasn't enough power. You weren't able to see the error in the ways. So how would you fix that? Well, you'd get more data points. You would increase the power that way. And you would decrease the chance of making that kind of error. If only we had looked a little bit more. Only if we had had more samples, we could have, boom, type 2 error. And power is, of course, related to type 2 error, and that it is 1 minus the type 2 error probability. So when you have a high power, you have very little type 2 error, and typically that's with a very high number in your sample. All right, so with alpha, the probability of making a type 1 error, everyone always sets for significance your p-value less than 0.05. Why is that? What's so special about 0.05? Nothing's intrinsically special about 0.05. It's just saying, well, there's a 1 in 20 chance of making this kind of error. And the guy who invented this whole thing was just like, you know what, 1 in 20 is good enough for me. That's really it. All right. So, confidence interval. We're going to spend some time on this, the most amount of time on this, because although it is the most straightforward thing from a name perspective, they will always ask you a question about this, because everyone gets it wrong. So let's go to our handy dandy, little thing here. So if we have a 95% confidence interval for our data, let's say it goes between 2.3 and 4.5, that's the 95% confidence interval. Which one of these is the correct answer? A, B, C, or D? Well, as you're reading through those, I'm going to kind of read through here on the purple of another way of saying confidence interval. It's a reliability of our estimation. Or you can say it's the confidence interval is going to include our value, or it won't. That's an important thing here. These are things that people are going to throw at you. You can also say it's a reflection of our confidence and our estimation, not necessarily the interval. What the heck does that mean? It's a reflection of our confidence in our estimation, not the interval. What? What do these words mean? What are these options saying? Are they all reliable? Well, let's look at these answer choices here. So a confidence interval is really telling you that we are 95% sure, if that's our interval, of course, that the value that we're looking for falls between this range. It's not saying 95% of the time it's going to fall between here. It's a reflection of our confidence in it. So you will see how A, B, and D all pretty much state the same thing. Well, they don't all state the same thing. B and D state the same thing. A states something false. It's not saying that 95% of our data falls between 2.3 and 4.5. And it's not saying that 95 times out of 100 we're going to get this. Which is pretty much what B and D are saying. What it's saying is we are 95% sure this is our answer. A confidence interval, once it's made, it's stating the confidence in our assumption. Whether or not the value is in there or not, whether or not our interval contains the true value or not, doesn't really matter. That's not what the confidence interval is saying. It's saying, hey, this is what we got. Okay. So what does this mean? Well, just like I wrote, once someone calculates an interval, that's it. There's nothing else to do. They're 95% sure of it. And it is not saying, well, if we repeat this 100 times, 95 times, we're going to get that interval, and 5 times we're going to get something completely different. That's not what it's saying. It's saying, hey, here's my answer. I'm 95% sure. So let's actually think of this as an example. Let's do another explanation that's not just, rephrasing, I guess, the same thing over and over again. Let's look at something I call the birthday example. When's your friend's birthday? Well, the 95% confidence interval is between the 27th and the 30th of April. Well, what is that saying? Well, that's saying, gosh darn it, I'm 95% sure that's the answer. It's not saying, 5 out of 100 times I'm going to say it's the 2nd of September or the 1st of December. No, it's not saying 5 out of 100 times I think it's something else. It's saying, yeah, it's this. I'm 95% sure. Just like when your friend asks you, what's the, who won the NBA Finals last year? You say, oh, it was the Raptors. I'm 95% sure. Yeah, I'm pretty sure it's the Raptors. Yeah. Not he'll ask you 100 times, and then 5% of the times you're going to say, oh, it was the Kings. No, that's not what a confidence interval is telling you. In this birthday example, confidence interval is telling you that you're always going to say between the 27th and the 30th, and you're 95% sure of it. Now, whether this is actually true or not, that's something completely different. That's something else, But it reflects your certainty of it. If it were to say 5 out of another 100 times, it'd be something else. That would not be a confidence interval. That wouldn't be reflecting your confidence. That would be a reflection of the probability of the likelihood of it being true. Not your confidence. Again, confidence interval is just your confidence. It's just your confidence in it. I'm certain, 95%, that it's here. It's not the probability that it's there. And it's not, 95% of my data is there. Okay, cool. All right. And confidence interval, depending on your threshold, is going to have a certain amount of z-scores. Remember, z-score is your how many standard deviations away from the mean you are, plus or minus. So what do I mean when I say that you've got different amounts for different amount of confidence intervals and stuff? Well, let me look right here. We can look at our handy dandy 4 dummies, and we can see right here. Oh. Here we're going to have our p-value, and here we're going to have our z-value here, z-score. We usually use this value, 0.05, but again, that's arbitrary. Sometimes for some data, you don't want to use 0.05, or you can use something like 0.1, or you can use 0.06. You know, it's up to the statisticians to determine, well, when is this cutoff good versus another cutoff? And when you need to find out actual, you know, what are the values you're going to use for certain cutoffs, you refer to a table. But in the back of your mind, you should just keep this in your head. So what can we know about confidence intervals? What can we conclude? Well, if confidence intervals for something like odds ratio, relative risks approach, or if it includes the value of 1, well, that's pretty bad. That means we can throw it out, because the value of 1, remember, for our relative risks and odd ratios means that there's no real significance there. It's not really telling us anything of value. If it doesn't overlap for 2 different data sets, hey, that's pretty nice. Okay. And this is looking for odd ratio and relative risk is including 1, because there it says that there's no real difference, remember. But for a mean, if it includes 0 as the difference, that's the same thing as including 1 for a confidence interval of an odds ratio relative risk. I mean, there's no real difference. So if there's overlap, it's bogus. If you're looking at odds ratio or relative risk, and the confidence interval includes the value of 1, it's bogus. If you're looking at the mean difference and it includes 0, it's bogus. And remember, confidence interval just states your confidence in the result. It doesn't talk about the probability. Whether your result is correct or it's not correct, it's not about the probability. Going back up, alpha, we typically set p is less than 0.05. Why? Because the guy who invented this whole study, this whole field, was just like, you know what? For my money, a 1 in 20 risk of committing a type 1 error, which is the worst kind of error, sent an innocent man to jail, is good enough for me.